Have you ever watched your dog, walk in circles over and over again before they finally settle down?
Oh, all the time.
Or what about when they just freeze and stare at a blank wall
Hmm.
like they're seeing something you can't?
Exactly, the classic ghost in the hallway moment. We usually just write that off as a weird dog quirk.
Yeah, just them being strange.
But what if those behaviors aren't quirks at all? What if they're actually, very precise reactions to things in the environment that we literally cannot perceive?
And that's our mission for this deep dive. We're trying to decode the astonishing neuroscience that's happening inside your dog's head,
Yeah.
and it's so much more than just a good sense of smell.
So much more. We're talking about two massive scientific discoveries that prove dogs have senses we normally think belong to, like migratory birds or whales.
Okay.
They have a biological compass that's tuned to the Earth's magnetic field, and they live in an auditory world that is just so much bigger and quieter than ours. It's a completely different reality.
Let's start with the compass. The one that, frankly, sounds like science fiction. The poop compass.
Right, and this is where, serious science meets the most mundane, everyday behavior.
I mean, watching a dog go to the bathroom?
And researchers did a massive study on this. They basically treated fields and parks like a huge outdoor lab.
And when you say massive, you mean it. This was, what was it, 70 dogs?
70 dogs, 37 different breeds,
Yeah.
and they collected data on, get this, nearly 1,900 defecations and over 5,000 urinations.
Oh.
This is a 2-year study. They were looking for one thing, a pattern,
And they found one, a really specific one.
breathtakingly specific. When a dog is undisturbed, and this is the key, when the magnetic field is calm, they overwhelmingly prefer to align their body
North-south.
along the north-south axis. Yes,
So they're either facing north or they're facing south when they do their business.
exactly. It's what's called an axial preference. The direction along the line is what matters, not which pole they're facing. But what's just as important is the avoidance.
What do you mean?
They don't just prefer north-south. The data show they actively avoid the east-west direction.
Okay, that's the tell. That proves it's not random.
It's the first really clear, measurable evidence for magnetic sensitivity in a dog's normal, everyday life.
But why? Why then? I mean, why does the magnetic field matter when they're, you know?
That's the billion-dollar question. The theory, at least, is about calibration. It's a moment when they're standing still.
Okay.
And they might be using that moment of stillness to sort of read the magnetic field and calibrate their internal map. It's like they're checking their compass against a known landmark for navigating later.
A quick system check. That actually makes a lot of sense, but you said something crucial there, when the magnetic field is calm.
Yes, and that's the invisible barrier. This whole behavior is completely dependent on the Earth's magnetic field being stable.
So if it's not stable,
The behavior is completely abolished. It just disappears. Their alignment becomes totally random.
wait, how often is the magnetic field unstable? I thought it was a pretty constant thing.
That's what's so wild. The researchers found that the magnetic field is only calm enough for this to work in about 30% of the daylight period.
Only 30%.
Yeah. For the other 70% of the time, there's just too much magnetic noise. Things like solar wind, other geophysical events, they just mess with the signal.
So for most of the day, their compass is basically offline.
It seems that way. They probably just switched to using their eyes, their nose, other cues. But that stable magnetic anchor is gone.
That has to have huge implications for other animal studies, right?
Massive. The study's authors think this might be why so many other magnetoreception experiments have been so hard to replicate.
Because nobody was checking the daily space weather report.
Exactly. They weren't accounting for these subtle daily shifts in the field's direction. So we know when it happens, but what exactly are the dogs sensing? Is it the strength of the field getting weaker or stronger?
Yeah, is it the intensity?
That's what people thought. But this research found something different. The thing that best predicted when the dogs stopped aligning wasn't a change in intensity. It was the rate of change in declination.
Okay, declination, that's the angle of the field, right? The actual direction the compass needle is pointing.
We got it. So think of intensity as the volume of the signal. Declination is the direction. They aren't listening for the volume, they're watching the needle. If the needle is stable, they lock on. But if that needle starts wobbling back and forth quickly,
The compass is unreliable and they ignore it.
they stop trusting it.
Yeah.
It shows they're sensitive to these tiny, rapid shifts in polarity.
That is just so much more sophisticated than I ever imagined. So how? How do they do it? Is there a little bit of metal in their ear or something?
The mechanism's even cooler, actually. It takes us into quantum biology. There's a specific molecule responsible for this. It's called Cryptochrome 1.
Cryptochrome 1 sounds like a piece of spy tech.
It basically is for biology. It's a light-sensitive molecule. We know a similar one helps birds navigate during migration.
So where is this molecule? Where is it in the dog?
This is the part that connects everything. It's found in the blue-sensitive cone photoreceptors in the retina of the dog's eye.
Hold on, in the retina, the back of their eye.
In the retina, yes.
Are you telling me they can literally see the magnetic field? That is, it's like a visual overlay, a biological heads-up display.
That is the leading hypothesis for how it works. That their magnetic sense is dependent on light.
Wow.
And the quantum physics behind it is, it's pretty out there. Basically, when light hits this Cry1 molecule, it creates a pair of electrons whose spin is really, really sensitive to the Earth's magnetic field.
So the magnetic field is physically interfering with these tiny electrons.
Exactly. And their brain interprets that continuous tiny disturbance as directional information. They probably don't see glowing lines in the sky, but they might perceive it as patterns of light and shadow that are locked onto the magnetic field.
An extra layer on their reality. And,
Right.
and this isn't in all animals.
No, and this is a fascinating evolutionary split. They found active Cry1 in dog-like carnivores. Dogs, wolves, foxes, bears.
The ones that roam and navigate large territories.
Makes sense, right?
Yeah.
But they're all like a cat-like carnivores. House cats, lions, tigers, and they did not find it.
So my dog has this superpower, but my cat doesn't.
Your dog has a light-up compass in its eyes, and your cat navigates differently. And that is just one of their invisible senses.
Okay.
If the magnetic field is their invisible map, then their hearing gives them this incredibly detailed picture of movement all around them. So let's shift from the magnetic world to the auditory one.
Right. We all kind of know dogs hear better than us, but the numbers are just staggering when you actually look at them.
They really are. And to get those numbers, scientists have to create what's called an audiogram. They train a dog to react to a specific tone, and then they find the absolute quietest level the dog can hear at each frequency.
So what's the difference? What's the gap between us and them?
It's mostly at the high end. So a young, healthy human, can hear from maybe 64 hertz up to about 23,000 hertz. That's 23 kilohertz.
And a dog.
A dog's range goes from about 67 hertz all the way up to 45,000 hertz.
45,000, that's nearly double our range.
Double our range. They're living in an ultrasonic world. Think about all the electronics in our homes, the power adapters, the screens. A lot of them emit a high-frequency hum that's totally silent to us.
But not to them.
To them, the house might be filled with constant high-pitched noise. Or they can hear mice squeaking in the walls, which communicate in ultrasound.
That's the ghost in the hallway right there. What about on the low end?
Yeah, that's another part of the ghost story. While their best hearing is in that 4 to 10 kilohertz range, their low end is still really impressive.
So they can hear deep rumbles we'd miss.
Well, they can detect low-frequency vibrations that might feel more like pressure to us. In the tests, poodles could hear a tone at 40 hertz, which is very low.
And those low sounds travel through walls, through the ground, so they could hear an approaching car or distant thunder way, way before we can.
Exactly. It's an early warning system.
Huh.
But the most mind-blowing detail for me isn't the frequency range. It's their sensitivity. It's how quiet of a sound they can actually detect.
How quiet are we talking?
Okay, so get this. One poodle in the study could hear a 4 kilohertz tone at -4 decibels.
Wait, negative decibels? How is that even possible? I mean, for anyone who doesn't know the scale, that sounds like a mistake.
It sounds impossible, but it just means the sound is quieter than the standard reference level we use for 0 decibels,
Yeah.
which is already the threshold of perfect human hearing.
So, quieter than silence.
Effectively, yes.
Yeah.
It's a sound that is functionally undetectable by a human ear, even if it's at a frequency we can hear. We're talking about the energy level of, like, a feather drifting through the air in a silent room.
So when my dog's head snaps up and he stares at nothing.
He's not paranoid. His biological HUD might be picking up a wobble in the Earth's magnetic field, or his ears are detecting a sound that's both too high-pitched and just impossibly quiet for us to ever hear.
They're just operating with a completely different set of data.
Two profound invisible realities at the same time. They're navigating with a compass that's literally tied to the cosmic energy of the planet. And at the same time, they're listening to a symphony of silent vibrations and ultrasonic chirps that paint a picture of life moving all around them.
It really makes you rethink the environment we build for them. All our electronics, the traffic noise. We have no idea how that might be affecting them. we could be creating this incredibly stressful sensory environment without even realizing it.
Absolutely. You're not just living with an animal. You are cohabiting with a creature that is constantly tuned in to the invisible architecture of the world in a way we are completely blind and deaf to.
So the next time you see your dog doing those slow, deliberate circles, just stop and think. They might not just be getting comfortable.
They might be finding true north, aligning themselves with a fundamental force of the planet that we can only measure with machines. They're just reading the Earth.
A mind-bending thought to end on. Thanks for taking us through that.